Welcome to this video on Thevenin's equivalent circuit. In this video we will determine the Thevenin's equivalent circuit for this top circuit. To begin with, the first step is to remove the load. The second step is to remove the source, and in this case it's a voltage source V1, so we will short it out. The next step is to find the Thevenin's equivalent resistance as seen from the load. The load was here, so we're going to be looking at the equivalent resistance from this perspective. As seen from here, we see that R1 and R2 are in parallel. So RTH is equal to R1 in parallel with R2. We can use the product over sum rule to calculate this value, which would be R1 times R2 divided by R1 plus R2. Substituting in the values that we have, this is equal to 3 ohms times 6 ohms divided by 3 ohms plus 6 ohms. This yields 2 ohms. So our Thevenin's equivalent resistance is 2 ohms. Now that we have that, our next step is to find the Thevenin's equivalent voltage. In doing so, we continue to leave the load disconnected, but we replace the voltage source. With the voltage source replaced, we have a series circuit with R1 in series with R2. And we can use the voltage divider rule in order to determine what VTH is. So VTH equals R2 divided by R1 plus R2 times V1. This is equal to 6 ohms divided by 3 ohms plus 6 ohms times 9 volts. Which equals 6 volts. Thus, we can now create our Thevenin's equivalent circuit where VTH is equal to 6 volts. Our RTH is equal to 2 ohms. And we can add our load back. We can now solve this equation for the voltage across the load and the current through the load. This concludes our video on Thevenin's equivalent circuits.